Now the next chapter that we are going to study is the next chapter name is what? A linear motion. Okay. The next chapter that we are going to study then is what? Linear motion. Okay. Guys, give the main heading, linear motion. Now in this chapter, the first point that we are going to study is the displacement. What is the first point? Displacement. Displacement is denoted by symbol S. Okay guys, give the first heading, displacement, and displacement is denoted by the symbol S. Displacement is denoted by what? Which symbol displacement will denote? Displacement is denoted by symbol S. Okay. Guys, give the heading, displacement. Now, what is meant by displacement, guys? Okay, first of all, let me tell you what is meant by displacement. Okay, displacement means what? Displacement is defined as shortest distance between 2 points. What is meant by displacement? Please everyone write down. Everyone please write down. Displacement is defined as shortest distance between 2 points. Displacement is defined as shortest distance between 2 points. Okay, guys, got it? What is meant by displacement? Displacement means shortest distance between 2 points. Okay. Now then, after that definition, write down the unit. Okay. See, there is a one word, SI unit. SI unit means what, guys? SI unit. It means standard unit. Okay. In mechanics, whatever the units we are using for the calculation, by default it is a SI unit. Means suppose mass. What is the, see, mass has a gram, kilogram, pound. All these are the, okay, units of what? Mass. But for SI unit of mass is what, guys? Kg, kilogram. Same length or distance. All these SI units is what? Meter. Okay. Then time. What is the SI unit of time, guys? Second. Then angle. Okay. SI unit of angle is what, guys? Radian. Means we can use degree also. But it is not a SI unit. Now SI unit means standard unit. Basically this is a French word. Système international. Okay. System means standard unit. Okay. Standard unit systems of international. Okay. Okay. So SI unit. Okay. You got it. So now displacement means what? Nothing but the shortest distance between 2 points. So what will be its SI unit? Okay. See, whenever I am saying SI unit means for energy SI unit is joule. For force SI unit is Newton. Okay guys, see the for power SI unit is a watt. Okay. See the every time I will say SI unit, because in mechanics for stress SI unit is Newton per meter square, for pressure is also Newton per meter square. Okay. So every time we are going to use whatever the units in this chapter is throughout mechanics, we are going to use by default SI units, everyone. So what is the SI unit of displacement? Okay, below that write down SI unit. SI unit. What will be its SI unit? Meter. Yeah. Okay. Now after meter, okay, everyone completed up to this point. SI unit, SI, capital S, capital I, SI unit, meter, small m. Okay. Now the next point is what, guys? Everyone, give the next. Velocity is denoted by small v. Velocity, it is denoted by small v. Now in velocity, please everyone write down. It is defined as rate of change of displacement with respect to time. What is meant by velocity? It is defined as, guys, write down. It is defined as rate of change of displacement with respect to time. Okay, everyone completed? So what is meant by velocity, guys? It is defined as rate of change of displacement with respect to time. Okay, so guys, got it? Now how we are going to write down mathematically velocity means what? See the point here, everyone, don't write anything. So mathematically, especially for those who want to give maths paper, okay, in maths you may have seen one term. Okay, there may be one question in your maths, in derivative find out the velocity. So they may have given x in terms of what? X means whatever displacement. In maths there is one question like that. This is 2t square plus 3t plus 1. Okay, suppose this is a question and we have to find out velocity by using this expression. Okay, we have to find out expression of velocity. Okay, so what is the expression we have to use? So mathematically velocity is what? V is equal to what? ds by dt. S stand for what, guys? ds by dt means derivative of s with respect to time. ds by dt means what? Derivative of displacement with respect to time. So this is what a mathematical definition, guys. Derivative of s with respect to time, ds by dt. Okay, don't worry about it. Those who want to give maths paper, if you are not able to understand these things, don't worry. This is just for mathematical definition, nothing else. Okay, we don't need this definition in mechanics. But those who want to give maths paper, mathematics, for mathematics, then this definition is very, very important. Okay, those who want to give maths paper means only for those who want to give maths paper means this is like a displacement. So here velocity will become what? Dx by dt, and it will become 2 into 2t plus 3. So this will become expression for velocity at a particular time. Okay, means if suppose time is equal to 2 seconds, so velocity will become what? So 2 into 2. So 2 into 2, instead of time, what we will put? 2. Okay, plus 3. Okay, guys, are you getting my point? Try to see the scenario here. So what will be the velocity? So 4, 8, 11 meter per second. Okay, only for those who want to give maths paper. Those who don't want to give maths paper, for them it is not necessary. Okay, just there may be a such type of question in maths you may get. Okay, only for the maths student. Okay, write down this mathematical definition, guys, just for our reference. Okay, but we don't need it, but just write down for our reference. But especially for those who want to give maths paper, this definition is very, very important to them, because most of the time there may be such type of question in maths. But those who cleared their maths, don't worry about this definition. Now everyone got this one? Everyone completed? So this is what, guys, mathematical definition of velocity. Now suppose if v is constant. If what, guys? If velocity is constant. Now what is meant by constant? Do not change with time. What is meant by constant, guys? Do not change with time. If velocity do not change with time, then, okay, if v is constant, then how we will define velocity? Velocity is what? S by t. How we are going to define velocity? What is meant by S? Displacement. What is meant by t, guys? Time. Everyone try to see the scenario. But this definition is applicable when? This definition is applicable when our velocity is what, guys? This expression is applicable when our velocity is what, guys? Our velocity is what? Constant. Okay, try to see the point here, everyone. Please, everyone, write down this one. Okay, completed, guys, everyone, up to this point. Okay, now see, SI unit of displacement is what? Meter. SI unit of time is what? Second. So then, what is meant by velocity? S by t. What is the unit of S? Meter. What is the unit of t? Second. So SI unit of velocity will be what, guys? SI unit of velocity will be what? Meter per second. So what will be SI unit of velocity, everyone? Meter per second. Now very, very important, everyone. So please write down this one. Okay, completed. Now the next point is what, guys? Given everyone, SI unit of velocity is what? Meter per second. Now the next point is what, guys? Acceleration. Acceleration is denoted by symbol small a. Okay. Acceleration, give the next heading. Acceleration. Acceleration is denoted by symbol small a. Acceleration is denoted by symbol small a. Now how we are going to define acceleration? Okay. Listen my words carefully. Now first of all, what is meant by velocity? Velocity means what? Rate of change of displacement with respect to time. That is meant by velocity. Now what is meant by acceleration? Everyone listen my words carefully. What is meant by acceleration? Acceleration means what? Rate of change of velocity. See, what velocity it will tell you? In 1 second, how much displacement we are going to cover. See, what is in general words? In general word, what is meant by velocity? Velocity means what? Oh, this bus has so much velocity or this person has so much velocity. It means what? In unit time, how much distance we are going to cover or how much displacement we are going to cover. That is meant by velocity. But what is meant by acceleration? Now listen my words. The rate of change of velocity with respect to time is called acceleration. What is meant by velocity? It is defined as rate of change of velocity. Guys, see the point now. Rate of change of velocity with respect to time. Please everyone write down. I will explain you these things. What is meant by acceleration by using one example. So please everyone write down how we are going to define acceleration. It is defined as rate of change of what, guys? Rate of change of what? Rate of change of velocity with respect to time. It is defined as rate of change of velocity with respect to time. Okay. Now guys, see, mathematically velocity, how we define velocity? ds by dt. And what is definition of velocity? The rate of change of displacement with respect to time. So now similarly, how we define mathematically? Mathematically, how we define acceleration? Mathematically, how we define acceleration, guys? A is equal to what? Here, velocity is what? Rate of change of displacement with respect to time. So here ds by dt. But then here what will be here? Here definition of acceleration is what? Rate of change of velocity with respect to time. So try to see the scenario. So acceleration become what, guys? What acceleration will become? So dv by dt. Okay, derivative of velocity with respect to time. Okay, so this is what a mathematical definition. Those who want to give mathematics subject, for them it is important. For other peoples it is not important. So don't worry, just write down this definition. If you don't want to give mathematics, okay, just write down this definition. Okay, good. Now try to see the next scenario, guys. Everyone, try to see the next point. So here we got it. Acceleration means, okay. Now if acceleration is constant, if what, everyone? If acceleration is what? Constant, then how we are going to define acceleration? Acceleration is equal to v minus u by t. How we are going to define acceleration? V minus u by t. Okay, I am going to explain meaning of each and every term. Okay, here, see, this is the standard term. Okay, you may study it during your class 4 also, this terminologies. Okay, just here I am. So where, what is meant by v? V stand for final velocity here. In this expression, what is meant by small v? Small v means what, guys? Final velocity. And this velocity will be in what? SI unit, meter per second. Then small u. What is meant by small u? Initial velocity. What is meant by small u, guys? Initial velocity. And initial velocity will be also what? In meter per second. Then small t. What is meant by small t? Time. Okay. Time is also in what, guys? Time is in second. Okay. SI unit of time is what? Second. Please everyone write down up to this point. Please everyone write down this one. Now see. Now what will be the SI unit of acceleration? Okay. See. Unit of velocity is what? Meter per second. What is unit of time? See. Seconds. Try to see the scenario here. So here. This is what? Meter per second divided by second. So what we can write here further? So meter second into second. So what will unit will become, guys? Meter per second square. Okay. Everyone getting my point? So what will be the unit of acceleration? So SI unit of acceleration will be what, guys? Everyone. SI unit of A. What will be SI unit of A? Meter per second. In mechanics, what is most important? Means first important thing in mechanics is drawing. Then second important thing is what? Units. Okay. Then the least important thing is what? Calculation. Okay. So first important thing is what? Drawing. Second important thing is what? Units. Try to see the scenario. So always be focused with unit. And in mechanics, almost except one or two situation, almost each and every situation we are going to use what? SI unit. What we are going to use? SI unit. So please everyone write down this one. SI unit of acceleration is what? Meter per second square. Now guys, I am going to take one example. I am going to explain what is meant by basically acceleration. We are going to understand what is meant by acceleration. We studied its definition, rate of change of velocity with respect to time. That is the definition I have given to you guys. Okay. So that is a general definition. This is not means this is a standard definition of acceleration. What is meant by acceleration? Rate of change of velocity with respect to time. But what is actually it is meaning? Okay, try to see the scenario. What is the physical meaning of acceleration and what we can interpret? Okay, try to see the scenario. Okay, suppose I am going to take two example with you guys. Example 1 first of all, and then example 2. Okay, try to see the scenario. Example 1 and example 2. Okay, now suppose acceleration here is what? 2 meter per second square. Okay. Acceleration is what? 2 meter per second. Suppose initially is what? When time is equal to 0 second. When time is equal to 0 second, our suppose velocity is what? 3 meter per second. Okay. Just imagine that. Okay. I am taking one example. Now my question is, after when time is what? 1 second, what will be the velocity, guys? What will be the velocity after 1 second? When time is 1 second, how much, guys? Okay, option number 1. Option number 1, 2 meter per second. Option number 2, 3 meter per second. Option number 4, 4 meter per second. Option number, first, second, third, fourth number option, 5 meter per second. So out of these 4 options, which options will be correct? Which option is correct? Okay. Fourth or which one? Fourth. 5 meter per second. Okay. So now guys, how we are getting this 5 meter per second? Try to see the scenario. How we are getting this 5 meter per second? Just observe the things here. Just I am going to explain. Just now we have seen acceleration is equal to what, guys? V minus u by t. Okay. And here acceleration is constant, guys. Okay. What I am saying? Here acceleration throughout acceleration is constant. Okay. So now A is equal to what? V minus U by T. Okay. So V is equal to what we can write? U plus AT. Can I write like this, guys? V is equal to U plus AT. Okay. So guys, what is V means what? Our final velocity means after 1 second. Okay. That is what our target. Initial velocity is what? When time is 0 second, initial velocity is what? 3. Acceleration is what? 2. Okay. And how much time? 1 second. Okay. How much time, guys? 1 second. Okay. Everyone, are you getting my point? Try to see the scenario. Time is what? 1 second. So what will be the velocity? 5 meter per second. Okay. So after 1 second, velocity will be what? Everyone? 5 meter per second. Okay. Now suppose time is what? 2 second. What will be the velocity? Everyone? What will be the velocity? After 2 seconds, what will be the velocity? Everyone? Just use this expression, guys. V is equal to, I derived this expression for this from above. So now guys, see, try to see the point here. Okay. So our V is equal to initial velocity by default 3. Acceleration is how much, guys? How much acceleration? 2 meter per second, and time is what? 2 seconds. Now after 2 seconds. Okay. Starting from 0th second to 2 seconds. Okay. So what will be the, guys, see? 3. 2 into 2, 4. So 3 plus 4, 7 meter per second. Okay. So this will become what? Velocity after 2 seconds will become 7 meter per second. Now suppose time is what, guys? 3 seconds. What will be the velocity? Suppose time is what? 3 seconds. So what will be the velocity now? How much, guys? 9. Okay, correct. Very good. So this velocity will become what? 9 meter per second. How we are getting 9 meter? Okay, see, simple scenario. So initial velocity again 3 meter per second. Initially, when time is 0 second. Acceleration 2 meter per second. Acceleration is not changing here, guys. See the scenario here. I am going to tell you what is the meaning of acceleration and how we are going to interpret it physically. Okay, try to physical meaning. Okay, now time is how much, guys? 3 seconds. Okay, so 3 into 3 plus 2 into 3 means this is what? 6 plus 3. So this will become what, guys? 9 meter per second. So after 3 seconds, we are getting 9 meter per second. Okay. Similarly, after 4 seconds, guys, how much we are getting? Velocity is how much? 11 meter per second. So this will become 11 meter per second. Suppose after time 5 seconds. How much velocity, guys? 13 meter per second. Okay, good. After t is equal to what, everyone? 6 seconds. How much velocity? 15 meter per second. Okay. Everyone, try to see the scenario. Now, what is the conclusion you can derive from this example? Can you tell me any conclusion by using this example? Okay, see, that acceleration constant I told you initially, huh? So you are telling me, sir, you are saying me, guys, you are saying me what? Acceleration is constant. That I told you initially only. Acceleration is constant, but what is the conclusion? What conclusion you can derive? I told you initially what is acceleration is constant here, but tell me conclusion. What is the conclusion you can derive from this one? Acceleration constant I told you initially, huh? At the beginning of this example. Guys, just observe the results. See. No. V is equal to U plus AT. That is the, okay. That is a equation. But from these results, tell me conclusion. From this, these are our results. Tell me conclusion from these results. Correct. Means what you are saying, if time changes by 1 second, guys, try to observe the scenario here. If time changes by, okay, try to see the scenario here. Try to see the scenario here. If time changes, you are saying correctly. Good, very good. So what you are saying? Time changes by 1 second, guys. Here, observe the things here. Just observe these results. Observe these results, everyone. If time changes by 1 second, what is happening? If time changes by 1 second, what is happening, guys? Here time changes by 1 second, what is happening? Velocity is changed by how much? Velocity is changed by how much? Means after every 1 second. After every 1 second, what is happening? How much is velocity changing? After every second, how? 2, correct? 2 means, see guys, means see the scenario here. Means if you observe this one, guys, try to observe the scenario here. Very simple discussion, okay, and but important one, very okay. Means other words, okay. So what is acceleration I have given? 2 meter per second square. But in other words, this 2 meter per second square, okay. Other words, 2 meter per second, I can write 2 meter per second per second. What does it mean, guys? Means every second our velocity is changed by 2 meter per second. Guys, are you getting my point? Try to see the scenario. What does it mean? What is the meaning of this one? Means for every second our velocity is changed by what? By how much amount our velocity is changing? By 2 meter per second. Okay, so you got it. So what is the meaning of acceleration? Means acceleration is tell us what acceleration will from acceleration what will come to know? Means acceleration will tell us that what will tell us? By every second how much velocity is changing. So here how much velocity is changing in every second? If acceleration is 2 meter per second square, so every second how much velocity is changing? 2 meter per second. Means see how I have written this one? 2 meter per second. So here velocity is changed by what? In every second a velocity is changed by what? 2 meter per second. Try to see the scenario. Okay. So if acceleration is 2 meter per second square, then in every second our velocity is changed by what? 2 meter per second. That's the definition of acceleration, guys. So what is meant by acceleration? Rate of change of velocity. See, rate. What is meant by rate, guys? What is meant by rate? In every second or every unit time, how much rate of change of velocity? This means what? In every second, how much velocity is changing. And here, as our acceleration is 2 meter per second square, so here velocity in every second, how much velocity is changing? 2 meter. Means see, sometimes, guys, sometimes people may get confused. Oh, acceleration constant means velocity is constant. It doesn't mean here velocity is not constant, but it means, but increment of velocity is uniformly increasing. It means what? If acceleration is constant means what? Our velocity is increasing uniformly. It means, just take an example of our bike. Okay, means bike, okay, if you consider bike, okay. So, see, this is what our accelerator, my hand is what, suppose this is what my bike's handle, okay, and just I am, see my hand, okay. So I am, see, sometimes some people may like this, vroom vroom, like that. So they, at that scenario, acceleration is not constant. But few people, what they do? They increases the accelerator linearly. What will happen? They increases the accelerator linearly. So it means what? In that scenario, acceleration is constant and velocity is, means, see, the best example is a train. In train, see, so they increases the velocity uniformly. That train driver, there will be there some handle there in his coach of the driver, train driver, okay. So increases the speed linearly, okay, like this, okay. Guys, are you getting my point? So that is meant by acceleration. So if there is an acceleration, it means there will be change in velocity. In that scenario, velocity is not constant. So guys, you got the meaning of acceleration. Okay. So what is meant by acceleration? Acceleration tells us, what acceleration will tell us? Okay. In every second, how much velocity is changing. Okay. That is what our acceleration. Now the next point is what, guys? Try to see the scenario here. Now the next point, next example. Okay. Don't write this one. Okay. I will give you time to write down these things. Okay. Just I want to before that. Now it is not always like that. Okay. Now suppose it is not always like that. Velocity will always increase. Okay, sometime velocity will increase, sometime what will happen? The reverse will happen. Velocity will decrease. Okay. So whenever there is a velocity will decrease, what will happen? In that scenario we call it as a retardation or deacceleration. When velocity is increasing, that scenario is what? Our vehicle is accelerating. When velocity is decreasing, in that scenario, our vehicle is retarding. Means there is retardation in that motion. Okay. When vehicle speed is increasing, acceleration in motion. When speed is decreasing, retardation or deacceleration. Okay. Guys, are you getting my point? So whenever velocity is decreasing, in that scenario, okay. Okay. Now I am going to take another example. Okay. Try to see the scenario. In that scenario, acceleration is what? There is what? Retardation. So whenever there is a retardation or decrease in speed, in that scenario, we have to consider acceleration in negative because there is a speed is decreasing. So suppose I am taking consideration retardation scenario. So whenever there is retardation, if they mentioned retardation in the question, guys listen my words carefully because we may get some such type of question. Retardation. Okay, retardation is what? 2 meter per second square. They just said retardation 2 meter per second. What they will say? Retardation is what? Retardation of so and so vehicle is what? 2 meter per second square. But during calculation that 2 meter per second, how we have to consider? Minus 2 meter per second. Okay guys, are you getting my point? Try to say the scenario. What we have to consider? Minus 2 meter per second. Okay guys, try to see the point here. So now again we will start our discussion. So suppose time is what guys? Time is what? 0 second initially. Suppose our initial velocity is what? Okay, when time is 0 second, velocity is what? Suppose 27 meter per second. Okay, how much velocity? 27 meter per second. Now guys, can you tell me after 1 second how much will be the velocity? After 1 second, how much will be the velocity? Anyone? How much will be the velocity after 1 second? Okay, 29, 31, 25 because here see the scenario here means here minus 2. So minus 2 means what? Our new velocity. Here if plus 2 velocity will increase, but if minus 2 it means what? Our new velocity will become how much guys? 25 meter per second. If time is what everyone? 2 seconds. So what will be velocity? 23 meter per second. If time is what? 3 seconds. How much velocity? 21 meter per second. If time is what? 4 seconds. How much velocity guys? 19 meter per second. Okay guys, are you getting my point? If time is what? 5 seconds. How much velocity? 17 meter per second. How much if time is what? 6 seconds. How much will be the velocity everyone? 15. Okay guys, are you getting my point? Try to see the scenario here. Okay, you got the meaning of acceleration. So what is meant by acceleration guys? Acceleration will tell us in every second how much velocity will change. Means if the acceleration is 2 meter per second, then in every second how much velocity will change? 2 meter per second. Okay. Guys, are you getting my point? If acceleration is 2 meter per second square, if acceleration is what? 2 meter per second square, it means our velocity in every second will change by how much? Is changed by 2 meter per second. Okay guys, you got both the example. This example is of acceleration. Here's velocity is increasing. This example is of what guys? Deacceleration. Okay, here velocity is what guys? What is happening with velocity? Velocity is decreasing. Okay, good. Please everyone write down these two examples side by side. Write down these two examples side by side. Please everyone. Here make it as a acceleration. In bracket acceleration. Here deacceleration. Another word for this one is what? Retardation guys. Okay, you should be familiar with these two both words. Acceleration, deacceleration or retardation. Please everyone. Now next point that we are going to study is equation of motion. Okay, Everyone give the heading equation of motion. Give the heading, everyone, equation of motion. Now this equation of motion is valid for, okay, valid for A is equal to constant. If A means what, guys? If acceleration is constant, then and only then equation of motion is what, everyone? If acceleration is constant, then and only then equation of motion we can apply, okay, valid for A is equal to constant, okay. So now try to see the scenario here. So first equation of motion is what, guys? The first equation of motion, everyone? What will be the first equation of motion? V is equal to u plus at. What is meant by V? Final velocity. What is meant by u? Initial velocity. Second equation. S is equal to what, everyone? Ut plus half at square. Okay. Ut plus half at square. And third one is what, guys? V square is equal to u square plus 2as. Okay. Everyone please write down this one. This is equation of motion. But it is applicable when? It is applicable when? Valid for what? When our acceleration is constant. Acceleration constant means, doesn't mean velocity constant. Acceleration constant means velocity increasing linearly. In constant amount our velocity will increase. Okay. So please everyone write down equation of motion. One important point, okay, I missed one point, guys, during acceleration, okay. Just give the one note, okay. Just give the one note, okay. For A is equal to constant, what? For A is equal to constant. If acceleration is constant, then we will have an average velocity. What will be the average velocity? V average will be equal to what, guys? V average, okay, everyone. V average is equal to what? What will be the average? Initial plus final divided by 2. So what is initial? U. What is final? V by 2. Or in other words, what we can write? S by T, okay. Please everyone. V average means what? What is meant by V average? What is meant by V average? Okay, its unit is what? Average velocity, okay, in meter per second. Where what is meant by V average? Average velocity, okay, average velocity in what, everyone? Meter per second. Okay, now try to see the scenario. If you equate these two things, everyone, if you equate these two things, so what we can write? S is equal to what? Displacement is equal to what, everyone? Displacement is equal to what we can write? S is equal to what? U plus V by 2 into T. Okay. Please everyone write down this up to this point. Make it as a note. Okay. And this is what our average velocity. Now we have studied equation of motion. This is one important note. Now the next point that we are going to study, see, this equation of motion is applicable everywhere, okay. Now the next equation of motion, try to see the scenario here. But see, equation of motion, condition for this equation of motion, what is the condition? Acceleration must be constant, that is what the condition, valid for A equal to constant. Now guys, the next point that we are going to study equation of motion, but we are going to study equation of motion in gravitational field. Okay, try to see the scenario. Give the next heading, equation of motion. Equation of what, guys? Equation of motion. Equation of motion in what? Equation of motion in what? In gravitational what, everyone? Equation of motion in gravitational field, okay. Please everyone, give this heading. Equation of motion in gravitational field. Equation of motion in gravitational field is applicable only when equation of motion in gravitational field, guys, write down everyone. Equation of motion in gravitational field is applicable when there is a gravitational force acting alone on the object. Is applicable only when there is a what? Gravitational force acting alone on the object. Okay, gravitational force acting alone on the object. Okay, what does it mean? Gravitational force acting alone. Okay, means there is only gravitational force will act on the object, no other force. And what is meant by gravitational force, guys? Weight. What is meant by weight? Weight of the object means what, guys? Gravitational force. What is meant by weight? Weight means what? Gravitational force of the object. Okay, I will explain you what is meant. I'm going to give 2 to 3 examples. By 2 to 3 examples you will clear. Okay, first of all we will see what is equation of motion in gravitational field. Okay, similar to this one. Okay, only few changes are there. Okay, here we have to study sign convention also. So first equation, same, initial velocity, here also initial velocity, sorry, final velocity, then initial velocity. Now instead of a, here we will use minus gt. Okay, what we will use? Minus gt. Strictly you have to follow this one, strictly, because these things we need in while dealing with projectile motion also, because in projectile motion on the object there is only one force will act, and that force is what? Gravitational force, everyone. So v is equal to u minus gt. So strictly we have to use this one. Then second, instead of s, what we will use? We will use y. What is meant by s? S means any displacement, just a displacement. Meaning of y is what, guys? What is the meaning of y? Y stand for vertical displacement. What is meant by y, guys? Y means vertical displacement. So y is equal to ut. T means time. Then half, here a, instead of a replaced by minus g. So minus half gt square. Okay, everyone. Then v square. Third one is what, everyone? V square is equal to what? U square. Instead of s, s is replaced by what? Here s. Here we replaced by what? Y. So minus 2gy. Okay. So this is what? These three are equation of motion in gravitational field, and this is applicable when there is gravitational force acting alone. Only gravitational force. Okay. Only gravitational force should act on the object. Which force should act on the object? Only gravitational force, no other force, only gravitational. No reaction, no resistance, anything should not be, no friction force, nothing. No external force, only gravitational force. And what is meant by gravitational force, guys? Weight. Weight is nothing but what? Weight is nothing but the gravitational force, guys. Everyone, try to see the scenario here. So this is what our gravitational force. Okay. So first of all, everyone, write down these three equations, and I am going to explain meaning of each and every term. Okay. So here, y means what? What is meant by y? We know meaning of all other terms. Y means what? Vertical displacement. Very good. And whenever we say displacement, what will be the unit of displacement, guys? Whenever we say displacement, what will be the unit of displacement? Meter. Okay. Displacement in meter. Then what is meant by g? Okay, we know this g. This is a standard term, but still we will write down for our reference. Acceleration Due to what? Due to gravity. Very good. What will be its value? 9.81 meter per second. Meter per second, not only per second square. 9.81 meter per second square. Okay, please everyone. So this is what our equation of motion in gravitational field. Okay, now try to see the scenario here further. Okay, now we are going to see some sign convention here. Before going further, we have to see sign convention for this equation of motion in gravitational field. Okay, see the sign convention here. First of all, sign convention for vertical displacement. What is meant by vertical displacement? Y. Vertical displacement Y. Okay, sign convention for vertical displacement Y. Okay, so what is vertical displacement here? Okay, so sign convention for vertical displacement. See, suppose this is what our point of projection. This is what our point of projection. What is meant by point of projection? What is meant by point of projection, guys? The point through which we are throwing the object. Okay, means suppose here I am throwing the object. Try to see the scenario here. This is what it is. Okay, just suppose I am throwing pen. This pen is visible to everyone. Now pen is leaving my place. Okay, leaving my hand. So this position, see, this position will be what, guys? This position will be what? Visible to everyone. So this position is what? Point of projection. Now this pen, okay, it goes down. Okay, so here this pen goes down. Now if the object going down below the point of projection, if the object going below the point of projection, then our Y will be what? If our object is going down below the point of projection, then our Y will be what, guys? Negative. Y will be what? What will be the Y? Vertical displacement will be what? Negative. Okay, try to see the scenario here. If now, so here object is what? Below. This is what? This level is what? Point of projection. So object going below the point of projection, then Y will be negative. Okay, and what is meant by Y? Y stand for what? Vertical displacement. What is meant by Y? Vertical displacement. Guys, don't worry. We are going to take a n number of examples. Through that examples, we are going to clear what is meant by Y. So don't worry. In projectile motion also we have to deal with this Y a lot of times. Okay. So this is what a Y. Y is in negative. Now the next point will be what? Everyone. So what will be the next point? Now here, if we are throwing the object above, means see, this pen is going up. Okay, see, this pen is going up above the point of projection. See. Okay, everyone getting my point? Okay, so this pen is going up. I'm not good in cricket, so please. Okay, so this pen is going up. It means what? Above the point of projection. It means what, guys? In that scenario, Y will be what? Vertical displacement will be what? Positive. So Y will be in this scenario will be what? Positive. Okay, if our Y above means if our point above the point of projection, then our vertical displacement is positive. If our final point is below the point of projection, then our vertical displacement is negative. Just now remember these things. Okay, while dealing with numericals, I am going to explain these things more. So don't worry, please everyone, write down this one. So this is what, guys, sign convention for vertical displacement. This is what? Sign convention for vertical displacement. Now then we are going to see sign convention for velocity. Okay, these points are related with what? Equation of motion in gravitational field. Okay, so then sign convention for velocity. Velocity when object in gravitational field only. Okay, so sign convention for velocity. If velocity is upward, guys, okay, if velocity is what? Upward direction, If velocity is upward direction, then v is what? Positive. If velocity is what, guys? Everyone, downward direction. In which direction, everyone? Downward direction. Then velocity is what? Negative. Okay, please everyone write down sign convention. Here when upward, velocity is what? Positive. When downward, velocity is what? Negative. Okay, please everyone. So now try to see the scenario. Okay, so we have a what, guys? Sign convention for velocity. Now the next point is what? Try to see the next point here. Now we are going to see in which cases. Okay, see, in the beginning, while after the giving the heading, I have given you one point. Okay, equation of motion in gravitational field is applicable when gravitational force is acting alone on the object. Okay, this is what the sentence I have given. Equation of motion is applicable when gravitational force acting alone on the object. Okay, try to see the scenario. Now guys, I am going to discuss some cases. Okay, some example. Okay, just one example. I am going to take 2 to 3 example. Okay, suppose one example. Okay, just try to see the scenario here. Okay, very slant means a high slope plane is there. Okay, there is a high slope plane. On that plane there is one object. Okay, see the scene. On this plane there is one object. Now my question for all of you, in this scenario, equation of motion in gravitational field, is it applicable? Yes or no? Here object is going down. What is the motion of the object? And guys, speciality of this plane is what? This is a smooth plane. Huh? This plane is what? Smooth plane. And object is going down due to motion of due to its weight. Huh? Plane is smooth plane means what? Friction force is 0. Now my question is, can we apply equation of motion in gravitational field? Huh? Listen my question carefully. Can we apply equation of motion in gravitational field in this example, in this scenario? Now what is the condition for equation of motion in gravitational field, guys? What is the condition? Oh, okay. There should be only gravitational force. There should be only gravitational force. There is a friction is 0. Okay, friction is 0. So is there in okay smooth plane? Huh? That's why I told you smooth plane. So can we apply equation of motion in gravitational? See, here there is what? A weight will be there. Okay, suppose we will say weight is what? mg. Huh? Okay, weight is what? mg. Okay, is there any other force on this object other than weight? Other than weight, any normal reaction will be there. So here see, though there will not be friction force, but still here we have a plane. If there is no plane, then it will be in air scenario. Means object will be in air. Okay, but what will happen? What is happening here, guys? What is happening here? This is what a plane. So if there is a plane, there should be what? Normal reaction. So here we will have a normal reaction. So now guys, equation of motion in gravitational field, is it applicable here? No, it is not applicable. Equation of gravitational field is not applicable. Okay. Guys, are you getting my point? You got this scenario. Now the next point. So equation of motion is applicable, is not applicable here. Now the next point, everyone. Next example. Okay. Okay. Suppose object is going down. Huh? If suppose object is going down. Okay. Suppose there is a mass of 100 kg. Okay, or 100 kg is very huge mass. Just 1 kg mass. Okay. 1 kg mass. It is going down. It is going down. Or instead of going down, going up. Huh? What guys? It is going up. Or it is going up. Huh? Okay. It is going up. and air resistance is there. Air resistance is not negligible. Air resistance is not negligible. Air resistance is not negligible. Object is going up. Okay. Suppose we have thrown the object. Okay. Some huge object we have thrown. And then there will be what? Air resistance. Okay. Okay. Air resistance is not negligible. So guys, now tell me, in this scenario, can we apply equation of motion in gravitational field? Why we can't apply? Because there is a, see, weight of the object is what here in this scenario? 1g. But as object is going up, means there will be what? Resistance to the object is what? Fr. Okay, F resistance. So in this scenario, how much forces will acting here? Two forces is acting on the object. One is its weight, 1g. Weight means what? Gravitational force. What is meant by weight, guys? Weight means what? Gravitational force acting on the object. So here also we can't apply equation of motion in gravitational field. Okay. Now the next scenario. Okay. There is one rocket. Guys, a rocket. We know, guys, rocket. Just now, few days before means today's is how much date? 28th, na? Okay. So few 10 to 15 days before, in Israel, means Gaza Strip, a rocket means from Gaza, Hamas people throwing rocket on Israel, like that. Okay, that scenario. So in rocket scenario, can we apply equation of motion in gravitational field? Why we can't apply equation of motion in? Okay, that is the thrust force there, guys. So correct. So here in that scenario where we have a what? Guys, there is what? A thrust. Thrust is doing what? Means there is a weight of the object, mg of rocket, but with the weight there is a thrust force. Okay, it is going up. Okay. So in that scenario also equation of motion in gravitational field is not applicable. Okay. Guys, are you getting my point? Try to see the scenario here. Now the next point here. Okay, here also not applicable. Now next example, try to see the scenario. So next example. Okay. This is one object or 2 kg mass. 2 kg mass is going up. Okay. Negligible air resistance. Negligible air resistance. Everyone. What? Everyone? Negligible air resistance. Now in this scenario, can we apply equation of motion in gravitational field? Can we apply, guys, equation of motion in gravitational field? Yes, here we can apply equation of motion in gravitational field. Okay, guys. So here not, here not, here not. Okay. I'm going to take one more example. Okay, everyone try to see the scenario here. I'm going to take one more example. It is very interesting example. See, these points are very, very important. Sometimes we may apply. Okay. There is a, guys, one pulley is there. There is a one pulley is there. Okay. A rope is wound around the pulley. What, guys? There is a one pulley. This pulley is what? Smooth pulley. What is this pulley, guys? Smooth pulley, okay. This is a smooth pulley. And whenever there is a smooth pulley, what we studied, guys? Whenever there is, in one question we studied in friction chapter, in previous chapter, what we studied? Whenever we have a smooth pulley, what is the importance of that one, guys? Whenever we have a smooth pulley, what is the importance of that? Can anyone tell me? Okay, no friction, smooth friction. But what is its important? What is its importance, guys? Both the side tension will be same. Okay. So both this side. So now guys, suppose this is what, 10 kg mass. This is what, 2 kg mass. Now, so, and we just release these masses from some platform. This initially these masses on some platform. This 2 kg mass and 10 kg mass, these two masses is on what guys? On some platform. Okay. These two masses on what? Some platform, and we release these two masses. What we have done guys? We release these two masses. Okay. So what we have done? We have released these two masses. Okay. So what will happen then? When we release these two masses, what will happen? This 10 kg mass will go down. Okay. Because its mass, its weight is more. And this 2 kg mass will go what guys? It will go up. Now my question is, can we apply equation of motion in gravitational field in this scenario? Can we apply equation of motion in gravitational field in this scenario guys? Why no? Why yes? Why no? See guys, see, if you observe this one, yes, force of the wire, correct, force of the wire or force of the rope, means on this 10 kg mass, its weight 10 g, but this side there will be what? Tension is there. So on this 10 kg mass, two forces are acting. What are the two forces? 10 kg tension. As wire has a smooth pulley, so here also tension on this side. Okay, everyone. So same tension. If it is not a smooth, tension will be different. Okay, and then it will come into the rotational motion question. The next chapter, after this chapter, we are going to study next chapter, rotational motion. Okay, then here weight is what? 2g. So here on 10 kg mass, how many forces is acting? Two forces. One is what? 10 kg tension on this side. Here 2 kg mass, weight 2g, tension force here. Okay. So here for 10 kg mass and 2 kg mass, can we apply equation of motion in gravitational field guys? No, we can't apply equation of motion in gravitational field. Okay. Guys, are you getting my point? So not applicable in this scenario. Okay. So out of this scenario, which scenario we can apply equation of motion in gravitational field? Out of this scenario, in which scenario? Only in this scenario we can apply equation of gravitational field, because on this object, which force is acting here? Only its weight 2g, no air resistance, but here we have a air resistance, so two forces is acting. Okay. So guys, please everyone write down these examples. Okay. These examples are very important to understand when to use equation of motion in gravitational field. Everyone, give the next heading, Newton's second law of motion. Okay. That's the, guys, entire mechanics is depend on this law. Entire mechanics, Newton's second law of motion. Newton's second law of motion. Newton's second law of motion. Okay. We will not go into its theoretical thing. We will not go into its definition. We don't need that definition. Directly I will tell you what is meant by Newton's second law of motion. So guys, see, in equilibrium, we studied earlier. Earlier we studied equilibrium means what guys? What we studied? Okay, equilibrium. Equilibrium means what? What is meant by equilibrium? State of balance. What is meant by equilibrium? State of balance. And when will be the state of balance? When net force on the object is 0. When net force on the object will be 0, or net resultant force will be 0. Net force on the object. What is meant by, guys? Try to see the point here. So equilibrium means what? State of balance. State of balance means what? Net force on the object. What guys? Net force on the object will be what? Everyone. What will be the net force on the object? Net force on the object will be what? 0. That is meant by equilibrium. So how to identify object is in equilibrium? There will be two scenarios. In one scenario, object is what? Stationary or moving with constant velocity. Okay. That is what, how to identify. Okay. Now, Newton's second law of motion. Okay, I will explain you what is meant by Newton's second law of motion. So, according to Newton's second law of motion, net force on the object. Net force means what? F net. And what is meant by net force? Summation of all forces. What is meant by net force, guys? Summation of all forces will be equal to what, guys? Mass into acceleration. There are a lot of forms of this Newton's second law of motion, but whatever the form we require, or in other words, what we can say? Summation of F is equal to what, guys? Ma. If forces in x direction, what we will take? Summation of forces in x direction will be equal to m into ax. If forces in y direction, summation of forces in y direction equal to m into ay. M means mass, a means what, guys? Acceleration. Okay, so this is the main form. Summation of forces means what, guys? What is the meaning of summation of forces? Net force is equal to what, guys? Mass into acceleration. Summation of forces in x direction equal to what? M into ax. Summation of forces in y direction equal to what? M into what, guys? A y. Okay, please everyone write down this one up to this point. Then after this I am going to explain one important point, guys. Please everyone write down this one. Okay guys, completed up to this point. Okay, now try to see the scenario here. Next point. Okay, now guys, what are the equilibrium equations? What are the equilibrium equations? Summation of forces in x direction. Okay, summation of forces in x direction equal to 0. Summation of forces in y direction equal to 0. And summation of moment about any point equal to 0. These are the equilibrium equation. Okay. These equilibrium equations are nothing but the Newton's second law of motion. Now what, guys? Summation of these equilibrium equations are nothing but the Newton's second law of motion. Now you will say how it is Newton's second law of motion. Try to see the scenario. I am going to explain you one important point. Suppose, guys, try to see the point here. Okay, equilibrium equations are nothing but what? Equilibrium equations are nothing but what? Guys, Newton's second law of motion. Equilibrium equations are nothing but what? Newton's second law of motion. Okay, try to see the scenario. Okay, I am going to give you one important note. Suppose velocity is constant. For v is equal to constant, what will be the value of acceleration, guys? If velocity constant, what will be the value of acceleration? What will be the value of constant? See, 0, correct. How we are getting 0? Means initial velocity and final velocity is same. So v minus u. Okay. So both will be same. What is meant by acceleration? V minus u by t. So initial velocity, final velocity and initial velocity will be same. And if initial and final velocity will be same, then this term, initial final same. So this will term become 0 and 0 by t will become what, guys? 0. So whenever velocity is constant, what will be the acceleration, guys? 0. And see, what is meant by acceleration? Acceleration will tell us in how much amount by velocity will change in every second. If velocity is not changing, then acceleration will be what, guys? In every second. If velocity is not changing, then acceleration will be what? 0. That is what the meaning of acceleration, guys. Acceleration means what? What will acceleration will tell us? That's what we studied earlier. Acceleration means what? In every second, how much velocity is changing. If v is constant, in every second, how much velocity is changing? 0. Okay, how much velocity is changing? Velocity is changing what, guys? Velocity is changing 0. So acceleration will be what? 0. Okay, guys, are you getting my point? Try to see the scenario here. Now, for in case of equilibrium, what is the situation for equilibrium? For the equilibrium, velocity is constant, and if the velocity is constant, what will be the scenario then? Summation of forces will be equal to what, guys? Yummy. So if velocity is constant, then acceleration will be equal to what? 0. So what we can write? Summation of forces will be equal to what? 0. Okay, guys, are you getting my point? Summation of forces in x direction will be also equal to what? 0. summation of forces in y direction will be also equal to what, guys? 0. Okay, so these are what? These are nothing but what, guys? These three are what? Equilibrium. What, guys? Equilibrium what? Equilibrium equations. Okay, these are nothing but what? Equilibrium equations. Okay, are you getting my point? Try to see the scenario here. So what we can say? Equilibrium equations are nothing but the special form of Newton's second law of motion. So in everything in mechanics, everything in mechanics is totally depend on Newton's second law of motions. Not only Newton's second law, Newton's third law, means Newton's all three laws. First law, second law and third law, means for every action, equal and opposite reaction, that everyone know. Okay. So guys, please everyone, write down this one. Then at the end, I will give you one sentence about this one. Please everyone, write down this one. And this point is very, very important, everyone. If velocity is constant, then acceleration will be equal to what, guys? 0. Always keep this thing in mind, because acceleration means what? What is meant by acceleration? In every second, how much velocity is changing? What is meant by acceleration? In every second, how much is velocity is changing? Okay. So please everyone, write down this point. Okay, completed, guys? Completed, everyone? Okay, now write down the sentence. Equilibrium equations are nothing but the special form of Newton's second law of motion. Equilibrium equations are nothing but the special form of Newton's second law of motion. Equilibrium equations are nothing but special form of Newton's second law of motion. Okay, guys, completed? Anyone have any doubt in this discussion? Okay, so this is all about Newton's second law of motion. Now the next important point is what? After Newton's second law of motion, try to see the next important point. Momentum. Okay, guys, everyone give the heading. Momentum. Okay, momentum means what, guys? Momentum means what? Mass into velocity. What is meant by momentum? Momentum means what? Mass into velocity, and its unit is what? In kg meter per second. Okay, so this is what a momentum. After momentum, so the next point will be what, guys? After momentum. Okay, everyone completed up to momentum? Okay, now the next point is what? Conservation of momentum. Okay, guys, everyone give the heading. Conservation of momentum. Okay, don't worry, while dealing with the numerical, I will explain you all these points. Okay, everyone give the heading. Conservation of momentum. What does it mean? Give the heading. Conservation of momentum. Now, what is meant by conservation of momentum? Total momentum. See the point, total momentum just before collision. What, guys? Total momentum just before collision is equal to what? Total momentum. See the point here. Total momentum just after collision. Total momentum just before collision will be equal to what, everyone? Total momentum just before collision will be equal to what, everyone? Total momentum just before collision will be equal to total momentum just after collision. Okay, collision, strike. Okay, these are the few words. Collision, strike, impact. Okay, These are the similar words. Okay, please write down this one. Total momentum just before collision will be equal to total momentum just after collision. Now the next point is what, guys? Kinetic energy. We will denote kinetic energy by Ke. Okay. So Ke is what? We may know this term. Ke is equal to. So Ke is equal to what, guys? Half mv square. Its unit is what? Capital J. Capital J stand for joule. If you are using abbreviation, then capital J. If you want to write down full, then J must be in smaller if you are writing joule. Because here joule is not a name of the person for us. Here joule is what? A unit. So guys, see. Everyone. Okay, so that is what a kinetic energy. So we know kinetic energy means what? Okay, please everyone write down kinetic energy. After kinetic energy, what will be the next point, guys? After kinetic energy, next point will be what? Potential energy. Kinetic energy. Potential energy, we will denote potential energy by what? PE. And what will be the potential energy? mgh. It is energy, so it will be in also joule. Okay, please everyone write down potential energy. You may know this term, guys, but don't worry, just write down. This is for our reference. Now the next term is what? Work. Okay. So work is equal to what, everyone? Work will be equal to what? Force into displacement. What will be the work, guys? Force into displacement. Okay. So W is equal to what? F into S. Okay. Its unit is what? In joule. Okay. Everyone write down. W is equal to what? Force into displacement. Okay, completed, guys, work. Now the next important term, guys, very important term. What will be the next important term? Power. Guys, if you observe, means a bulb, AC. Suppose AC is consuming power of 1000 watt. Okay, just imagine that. Okay, AC is consuming power of 1000 watt. Okay, AC is consuming how much power? 1000 watt. What is meant by 1000 watt, guys? What is the meaning of 1000 watt? Or one normal bulb. Okay, normal LED bulb, 15 watt. Yes, joule per second. Very good. It means what? It means what? 1000 watt. It means what? AC is consuming every second 1000 joule energy. What is it means? What, guys? AC is consuming work of 1000 joule of electrical work in every second. If AC power is what? 1000 watt. Okay. It means what? Our AC, air conditioner, is consuming 1000 joule of energy. What means what? What is the meaning of what, guys? Joule per second. And what is meant by joule? Joule is unit of what? Work. So how will define power? What is meant by power? Power is defined as work done per unit time. What is meant by power? Work done per unit time. Okay, please everyone write down. Please everyone write down. It is defined as, okay, everyone has given the heading power. Okay, below that just write down. It is defined as work done per unit time. Okay, what is meant by power? It is defined as work done, what, guys? Work done per unit time. That is meant by power. Okay, everyone, are you getting my point? So we got it, power. So how we write down mathematically work done per unit time? Okay, means what? So power will be equal to what? Work by time. Power will be equal to what, guys? Work by time. And what is meant by work? F into S. What is meant by work, guys? F into S. Time means what? T. We can write down here. F into S by T. Can I write like this, guys? Mathematically, check it. Check it, everyone. S by T. Can I write like this? And what is meant by S by T? What is meant by S by T? Displacement by time, velocity. So power will be equal to what, guys? What will be power? Force into velocity. What is meant by power, guys? Force into velocity. And what is the unit of power? What will be the unit of power? Work unit is what? Joule. Second. So we can say watt. See, if I am writing complete, then small w if I am writing watt, or in other words, or we can say joule per second also. Okay. So guys, are you getting my point? Try to see the scenario here, everyone. Okay. So watt means what? Joule per second. Okay. Please everyone, write down this one.